Despite completing 85–90% of its mission objectives, Boeing's Starliner faced a critical setback. Helium leaks and thruster failures led to an empty return, leaving us to question, what does this mean for the future of Boeing's space program? On September 7th, 2024, the Starliner capsule touched down at White Sands Space Harbor in New Mexico. The landing was successful, but something was noticeably missing. Astronauts Suni Williams and Butch Wilmore were not on board. The contrast between the capsule's safe return and the absence of its intended crew highlights the gravity of the situation. NASA's decision to deem the Starliner too risky for a crewed return stems from significant technical issues that arose during the mission. As we explore the events that led to this empty landing, we'll uncover the complex decision-making process behind NASA's call. What exactly happened during Starliner's journey, and how will it impact the future of space exploration? The Starliner's journey was far from smooth sailing. What critical malfunctions occurred during the 3-month mission that forced NASA to make the difficult decision to bring it back empty-handed? The answer reveals a tense battle against time and technology. On June 5th, 2024, Boeing's Starliner capsule lifted off with high hopes and ambitious goals. However, as the days turned into weeks, that canvas began to show signs of trouble. The first hint of problems came when 5 out of 28 reaction control system thrusters failed initially. And these thrusters are crucial for maneuvering the spacecraft, and their malfunction raised immediate concerns. But this was just the beginning of Starliner's challenges. As the mission progressed, more serious issues emerged. Helium leaks were detected, affecting the propulsion systems. These leaks threatened the capsule's ability to maintain its orbit and perform necessary maneuvers. NASA and Boeing engineers worked tirelessly to understand and mitigate these problems. But the situation remained precarious. Perhaps the most concerning discovery came when NASA and Boeing identified that the doghouses containing propulsion equipment were operating at higher temperatures than expected. This overheating caused Teflon seals to bulge, restricting propellant flow. The implications were severe. Not only did this contribute to the thruster failures, but it also posed a potential risk to the safety of any crew on board. As the mission approached its 3rd month, NASA faced a difficult decision. The technical issues plaguing Starliner posed a significant risk to human safety. Despite the spacecraft completing 85–90% of its mission objectives, the agency had to prioritize crew safety above all else. On September 6, 2024, after nearly 3 months docked at the International Space Station, the decision was made. Starliner would return to Earth without astronauts Suni Williams and Butch Wilmore. The crew, who had been preparing for this mission for months, now faced an extended stay on the ISS, an additional 5 to 6 months beyond their planned mission duration. While the capsule's safe landing at White Sands Space Harbor in New Mexico demonstrated some level of success, the absence of its crew underscored the gravity of the technical challenges encountered. NASA's decision to leave Starliner docked to the ISS for an extended period wasn't made lightly. This extra time allowed engineers to conduct extensive tests and gather crucial data on the spacecraft's performance. Every day spent at the station provided valuable insights that could help prevent similar issues in future missions. As Starliner's extended stay on the ISS drew to a close, a $4.2 billion question loomed large. What would it take for Boeing to salvage its investment and regain NASA's trust? The path forward is fraught with technical hurdles and potential consequences for the entire commercial crew program. Boeing's Starliner program, born from a $4.2 billion contract with NASA in 2014, was meant to usher in a new era of commercial space travel. This investment, significantly higher than SpaceX's $2.6 billion for its Crew Dragon, set high expectations for Boeing's performance. However, the recent empty return of Starliner has cast a shadow over these ambitious plans. The financial implications of this setback are substantial. Boeing now faces the prospect of additional test flights and extensive modifications before achieving human spaceflight certification. Each delay and each test flight adds to the already considerable cost of the program, putting pressure on Boeing to deliver results. Steve Stick, NASA's Commercial Crew Program Manager, acknowledged the challenges ahead, stating, "Clearly, we got some work to do." This understated remark belies the complexity of the situation. Boeing not only address the technical issues that plagued Starliner, but also rebuild confidence in its ability to deliver a safe and reliable spacecraft. The contrast between Starliner's struggles and SpaceX's successes is stark. While SpaceX's Crew Dragon has been regularly ferrying astronauts to and from the International Space Station, Starliner has yet to complete a crewed mission. This disparity raises questions about Boeing's future role in NASA's Commercial Crew Program. The future of Boeing's role in NASA's Commercial Crew Program hangs in the balance. The company must demonstrate its ability to overcome these technical hurdles, manage costs effectively, and deliver a spacecraft that meets NASA's exacting standards for human spaceflight. The coming months will be crucial as Boeing works to address the issues identified during Starliner's recent mission and charts a course for the program's future. As Boeing charts its course forward, Starliner's empty return offers a rare glimpse into the complexities of space travel. What can this high-stakes practice run teach us about the future of human spaceflight? The answer lies in the valuable lessons learned from this unexpected turn of events. NASA's decision to prioritize safety over the completion of a crewed mission underscores the paramount importance of caution in human spaceflight. This choice, while disappointing for the crew and Boeing, exemplifies the rigorous standards that govern space exploration. It's a stark reminder that in the unforgiving environment of space, there's no room for compromise when it comes to astronaut safety. The technical challenges faced by Starliner have provided a wealth of data and insights that will shape future missions. One of the most critical lessons learned relates to thermal management in space vehicles. The overheating of the doghouses containing propulsion equipment led to unexpected complications, causing Teflon seals to bulge and restrict propellant flow. This issue highlights the need for more robust thermal control systems and improved seal integrity in future spacecraft designs. Moreover, the helium leaks encountered during the mission have prompted a reevaluation of materials used in space vehicles. NASA and Boeing's investigation revealed that the leaks were likely caused by seals degrading from exposure to propellant vapor. This finding emphasizes the importance of selecting materials that can withstand the harsh conditions of space for extended periods. The Starliner mission also reinforced the critical role of redundancy in space systems. Despite the failure of multiple thrusters, the spacecraft was able to continue its mission due to the presence of backup systems. This redundancy proved crucial in ensuring the capsule's safe return, even if it couldn't complete its intended crewed mission. These technical lessons extend beyond the Starliner program. As NASA sets its sights on ambitious goals like returning to the Moon and eventually reaching Mars, the knowledge gained from Starliner's challenges will inform the development of future spacecraft. The issues encountered serve as a valuable case study in the complexities of long-duration spaceflight and the importance of rigorous testing and validation. The empty return of Starliner, while not the outcome Boeing or NASA had hoped for, has provided an invaluable learning experience for the entire space industry. It serves as a reminder that progress in space exploration often comes through overcoming setbacks and learning from unexpected challenges. Each problem encountered and solved brings us one step closer to more reliable and safer space travel. Despite completing most of its mission objectives, technical issues forced NASA to prioritize safety over ambition. As we look to the future of space exploration, including missions to the Moon and Mars, the lessons learned from Starliner's journey will prove invaluable. The empty capsule that returned to Earth carries with it a wealth of knowledge, reminding us that in space exploration, every challenge overcome brings us one step closer to the stars